CNC machine calibration for woodworking. In CNC woodworking, precision is everything. You can have premium hardwood, expensive router bits, advanced CAD software, and a powerful CNC machine, but if the machine is not calibrated correctly, the final results will never look truly professional. And honestly, this is one of the most overlooked parts of CNC woodworking. Many operators struggle with inaccurate dimensions, poor fitting joints, vibration, rough edges, or inconsistent cuts, without realizing that the real problem is often machine calibration. A properly calibrated CNC machine delivers cleaner cuts, better accuracy, smoother finishes, and more reliable production. So today, we're going to explore what CNC calibration actually means, why it matters so much, and how professional workshops achieve extremely precise CNC results. What is CNC machine calibration? CNC calibration is the process of adjusting the machine so that every movement is as precise as possible. In simple words, when the machine is told to move 100 mm, it should move exactly 100 mm. Not 98. Not 102. Precision matters enormously in woodworking because even tiny dimensional errors can ruin cabinet assembly, joinery, furniture alignment, and finishing quality. Professional CNC furniture production depends heavily on repeatable precision. Without proper calibration, even high-end machines can produce poor results. Signs your CNC machine needs calibration. Many calibration problems appear gradually over time. At first, the errors may seem small. But eventually, they become impossible to ignore. Some of the most common warning signs include incorrect dimensions, circles becoming oval, rough edges, excessive vibration, and poor repeatability. Sometimes cabinet parts stop fitting correctly. Other times the machine begins producing inconsistent cuts. And honestly, even tiny alignment errors can create major problems in furniture production. Checking the CNC axes.
One of the most important calibration steps is checking the X, Y, and Z axes.
These axes must move smoothly, remain perfectly aligned, and avoid mechanical play. Even small alignment issues can affect precision, edge quality, and cutting consistency. Professional CNC operators regularly inspect linear rails, bearings, belts, and ball screws to ensure stable machine movement. Because in CNC machining, stability is everything. Calibrating the stepper motors. Stepper motors control machine movement. If the motor settings are incorrect, the CNC machine will not move the correct distance. For example, a programmed 100 mm movement might actually become 98 mm, or 102 mm. And that small error becomes a huge problem in furniture manufacturing. Professional operators calibrate motor steps carefully using digital calipers, measuring indicators, and precision tools. Because accurate motion creates accurate furniture parts. Why CNC table flatness matters. The CNC spoil board or table must be perfectly flat. If the surface is uneven, cutting depth changes, engraving becomes inconsistent, and finishing quality suffers. This becomes especially important in cabinet production, nesting, and precision engraving. That's why professional workshops periodically resurface the CNC table. This process creates a perfectly level cutting surface and dramatically improves consistency. Mechanical play and machine rigidity. Mechanical play is one of the biggest enemies of precision. Tiny unwanted movements inside bearings, belts, rails, or screws can create vibration and dimensional inaccuracies. And honestly, this is one of the reasons professional CNC machines are built with extremely rigid frames. A rigid machine produces smoother cuts, cleaner edges, less vibration, and more stable machining. Meanwhile, flexible machines often create chatter marks and rough surfaces. Spindle calibration and runout. The spindle is the heart of the CNC machine. It must rotate smoothly and remain perfectly centered. If the spindle has excessive runout, it can create vibration, rough finishes, tool wear, and unstable cutting. Professional CNC workshops regularly inspect spindle alignment and bearing condition to maintain cutting precision. Because even the best router bit cannot perform properly inside a poorly aligned spindle. Software calibration and machine tuning. Modern CNC machines rely heavily on software settings. Parameters like acceleration, motor tuning, travel limits, and movement smoothing all affect machining quality. Professional operators constantly optimize these settings to improve precision, smoothness, and repeatability. And honestly, even small software adjustments can dramatically improve machine behavior. Maintenance is part of calibration. Calibration is not something you do only once. CNC machines constantly experience vibration, dust, wear, and thermal expansion. That's why regular maintenance is critical. Professional workshops routinely clean rails, lubricate moving parts, tighten components, and inspect machine wear. Because long-term CNC precision depends heavily on maintenance discipline. How professionals achieve extreme CNC precision. Professional CNC accuracy comes from combining calibration, maintenance, quality tooling, machine rigidity, and operator experience. The best CNC workshops continuously test and optimize every part of the machining process. Because precision is not created by one single adjustment. It's the result of hundreds of small optimizations working together. And honestly, this attention to detail is what separates average CNC woodworking from truly professional production. Final thoughts. CNC machine calibration is one of the most important foundations of professional woodworking. Without proper calibration, dimensions become inaccurate, cuts lose consistency, and finishing quality suffers. But with proper setup and regular maintenance, a CNC machine can produce incredibly precise cuts, clean joinery, smooth finishes, and highly repeatable results. At the end of the day, CNC woodworking is not only about powerful machines. It's about precision, stability, optimization, and understanding how every detail affects the final product.